Okay, so for those of you guys just joining us, we talked about the alternate definition of a derivative, and then we started this example. If you don't understand this, you could read it in the book. Why this is the same thing as finding the using the definition that we learned yesterday, using the limit as h goes to 0 with the difference quotient. How this really, another way to say this is this, okay? So we're now doing an example problem. So we did these steps. You guys feel comfortable with these steps? So let's just keep going then. Adelante. Okay, so x minus 1 minus a plus 1. Okay, so the 1's cancel, right? So we're just going to have x minus a at the top, which is quite a relief because I have x minus a at the bottom that I wanted to cancel. Right? And yes?
I have a question.
Yes.
Like do you really have to write like limit x equals a for each thing? Like,
yes.
Because like, can you put like 0 signs like would they
no.
That?
That's not that much. It's not that much writing.
You like forget sometimes.
No. But yeah, you just have to do it.
How did you cancel out
the ones?
Yeah.
Because you have minus 1 and then you have plus 1 here.
Oh.
Yeah. Okay, so that was beautiful. I'm going to cancel that out. So the limit as x goes to a. But don't worry, we're not going to be writing that all the time because we're not always going to be using limits. Okay, the limit as x goes to a of 1 over square root of x minus 1 plus a minus 1, square root of a minus 1. And now, can I actually plug in? Substitute? Yes, so now, Sky, do I have to write limit? No. So now I could actually just say 1 over. Now, it's kind of confusing because you have two letters that both look like variables, but the x is going to take the a now, right? Right? Why?
Yeah,
so basically the x, I'm going to substitute a for all the x's.
Oh.
Right? And so that is going to be 1 over 2 times the square root of a minus 1. And that's going to be our answer. Or you can say 2 times a, or you could say 1/2 times a minus 1 to the negative 1/2. You know what? You can, but we don't care about that anymore. We were just kidding in Algebra 2. We don't care about radicals in the denominator. Yeah, it's fine.
Wait, why is it negative?
Because it's in the denominator.
So we can leave it at the 1 over.
No, this is just.
Oh, okay.
Yeah.
Is the other 1/2 to the power of?
No.
No.
No, it's just the. Let me write it again. 1/2 times a minus 1 to the negative 1/2. The 1/2 makes it a square root. The negative makes it in the denominator, right?
Oh.
So you can write it either way. Okay? And that is the derivative. That gives you the function of the derivative function for this f of x, square root of x minus 1. Yes?
So when they give you an a equals this, you plug into that?
Yeah, and then this is the general equation for a derivative, any derivative. So, okay, so in a sense, if I just use regular notation, if f of x equals square root of x minus 1, we just found that f prime of x equals 1/2 times x minus 1 to the negative 1/2. We just said it with a, right? It doesn't really matter whether that's called a dummy variable. That could be a, it could be x, it could be j. It doesn't matter. It's a dummy variable, right? Now, if I ask you for a specific point, if I ask you for f prime of, so when you say a, that a is always representing a constant. So that's saying like if you want any number, you can plug in that number, right? So for example, if I wanted to find the derivative if I want to find f prime of 0, for example, then I would plug in 1/2 times 0 minus 1 to the negative 1/2, right? But then that's actually irrational, so that doesn't work. Which leads us to our next. That doesn't work because it's irrational, right? I mean, imaginary, so that leads us to our next question, which is, how does the domain, okay, does that answer your question though? Okay. How does the domain of f of x compare to the domain of f prime of x? Do you guys remember what domain means? The set of all the possible x values. So how does the domain of f of x compare to the domain of f prime of x? Well, f of x was the square root of x minus 1. F prime of x is, okay, let's just write it like this because I think you guys feel more comfortable with this. X minus 1. Okay, how do the domains compare? Okay, you can move seats if you're in a seat that where you can't see very well. What's the domain of the top? It's a whole number? Can we pick any x value? Can we put any real number in here? All the real numbers have to be positive?
Greater than 1.
Greater than 1. Greater than or equal to 1, right? Because I cannot have 1/2 because 1/2 minus 1 is negative. I can't have 0 because 0 minus 1 is negative 1. So can I have 1? Yes, because 1 minus 1 is 0, and I know how to do the square root of 0. So basically my domain is going to be starting at 1 and going all the way to positive infinity, right? That's the interval notation, or you can say all the x values such that x is greater than or equal to 1. Those are two ways to say it, right? What about the second guy, the f prime? What's the domain there? Well, isn't the radical situation is the same? I could have any number. Hi. Uh-huh. Are they testing? Oh, okay. Okay. So can I have, so again, in this radical I can have anything that's greater than or equal to 1. Wait, can I equal 1? Greater than 1, because this time I can't have 0 in there because that would make a 0 in the denominator, right? Is there any other restriction? That's pretty much it, huh? Okay, so here the domain is this. It seems so similar, but it's not. One of the mathematical practices in Common Core, like a habit of a good mathematician, is attention to precision, to be precise. Oh, here's my necklace. I've been looking for it. I knew it was going to pop up in some pocket. Just didn't know when it would be. Or where. Okay, so precision is important. Okay? Questions? Okay, wonderful. So wait, what does that tell us? What conclusion can we make based on this example here? Well, based on the two domains that we found, why do you think I put this in there? What do I want you to take away from this? What about the derivative? So how does the derivative of a function compare to the derivative of its, the domain of a function compare to the domain of its derivative? Do they have to be the same? Are they the same here? No. So they don't always have to be the same. So this is to let you know that the domain of a derivative function is not always the same as the domain of its regular function, the original function, okay? So just keep that in mind, all right? Yeah? Okay, keep it in mind. All right, próxima. Okay, you try. Your turn. Your turn. The next two problems. I'm gonna pause this video for a sec. I know this is kind of tedious. You have a lot of little square roots to write. You know that the number one errors for calculus students is not calculus errors? They're algebra errors. Mm-hmm. Oh, really? Oh. Okay. There's my answer. Did you guys get that? Why did they show up yesterday?
Wait, didn't they? Yeah.
He forgot? Isn't it like, didn't they just take like $3,000 from you guys?
Yeah. Well, we paid.
$100 each.
Yeah.
$3,000. How could they forget?
He forgot like seriously? He just forgot like Danny felt bad, man.
Once you finish, do the next problem. Find the equation of the tangent.
You're the one that suggested that number.
Okay, let's discuss the next one, okay? I'll still rock around if you're still having trouble with the first one, but so now that we found, okay, you should be able to get to this equation for the derivative. That's a derivative function. But now we want to find the equation of the tangent line at a certain point. This is an equation, a general equation, but we now care about when x equals 2. So to find an equation of any line, what do you need? A slope and a point, right? We need a point and we need a slope. Well, how do we find the slope of a tangent line? The slope of the tangent line is really just the derivative at that point. So how can we notate that? The slope is going to equal f. Slope is going to equal f prime, right, of x, right? But x at where? At 2. So you can say it like that. So the slope is f prime of 2. See how we use these simple symbols to encapsulate a lot of meaning. In order to be able to have the privilege of using this little f with a little apostrophe and the parentheses and the 2, you have to understand limits. You have to understand all these things. You have to understand geometry and algebra and limits. So basically this is saying, f prime of 2 is saying, this is the slope of this, like the f of x function, find a derivative of that function using limits, and then plug 2 in to the x to find the slope of the tangent of that original function at that point x equals 2. Now, what is my point going to come from? Which point do I care about? When x equals 2, and what's the y value when x equals 2? F of 2, right? I mean, yeah, you're going to figure it out, but you see how this, I'm putting in a generic way so that you could apply it to any other problem. The slope is going to be f prime of 2. The point is going to be 2 comma f of 2. You see? F of 2 is different from f prime of 2, right? By the way, if I asked you for the normal line, you would use the same point, but instead of doing the slope being f prime of 2, it's going to be the opposite reciprocal, right? Because it's going to be perpendicular. So it would be negative 1 over f prime of 2, right? Because you're going to do a reciprocal and negate it, right?
So repeat that.
So if I asked you for the normal line, which I didn't.
So you can't just say f prime of negative 1.
No, that's different. That's different. Okay, because like I don't know what this function looks like, right? Let's just say the function looks like this. I'm telling you to find the slope here and do the opposite reciprocal of it, right? That's 1 over the slope of the normal is going to be 1 over f prime of 2 negative, right?
If you were to do f prime of negative 1 over 2, you'd be finding
That's over here,
Yeah.
negative 1 over 2, you would be finding that tangent. And that's not what I want at all, right? See how those are different? Did you get that, Sky?
So that's how I would write it if I wanted to.
The normal, yeah. Okay, anyway, so this is what I'm looking for. So now I have to just go ahead and find those. Do you guys know how to find f prime of 2? Yes. F prime of 2 is going to be, just plug 2 into this, right? So 2 over the square root of 2 squared minus 1, which is 2 over square root of 3, okay? And like I told you, we don't really care so much about that anymore, but if you really like to, it's okay, it's, I mean, for a number like this, I guess it's nice to 2 rad 3 over 3, but it's really fine, okay? Maybe with calculators nowadays, maybe that's why we don't care anymore, I don't know, I'm not sure. Okay, that's the slope. Now we just need to find out what f of 2 is, right? F of 2 is plugging it 2 into this, which is rad 3. So now we're just going to use which form of a line? The point slope, that's the easiest one, right? So we're just going to do y minus rad 3, okay, because this is rad 3, equals 2 rad 3 over 3 times x minus 2. And you could really leave it like that if you want. Okay? Questions? Is that okay? Or does anybody, yeah.
Did you put, okay, you know how you got from 2 over rad 3 equals 2 rad 3 over 3? Did you do that just so you wouldn't have
The rational, the radical in the denominator?
Yeah.
I don't care about the radical in the denominator, but they were like worried about it because in algebra 2 they always teach you should always rationalize the denominator, but we don't really do that anymore. Yeah. Okay? Questions? Did anybody have trouble getting to this solution over here? You guys are okay with the rationalizing the numerator? Okay, so just be careful with your algebra, and now let's talk about notation because that's really important, okay? Because it's going to be confusing and there's all these different ways to say the same thing, but you have to be familiar with all of them, okay? So why all the notation? It says the prime notations, f prime and f and f prime, and y prime. By the way, that's the same thing, okay? F prime or y prime, it's the same because f of x is really just y, right? Those come from our friend Newton, okay? So this year, you guys, please remind me, in the spring we should try to go see the Calculus the Musical. Last year, 2 years ago, I went with, I took up my calculus class. They did it at West Adams High School, which is where my friend works, and it's pretty close to like Stella. What? Calculus the Musical. It's a musical. It's fun, but it's fun when you watch at the end of the year because you get all the jokes because you know calculus. Yeah, like there's like I mean, there's like it's fun. There's like Eminem. There's like rap. I mean, Eminem comes. No, just kidding. Like, but there's like rapping. There's like an Eminem song. Like they take old songs and they change it into calculus words. You know, like it's fun. But it's about the history of calculus, and it's like about Newton and Leibniz, because Newton and Leibniz both kind of discovered calculus at the same time from different angles, and they both are like they kind of fought for like who should have the right, who should say that they invented calculus. Yeah. And so it's kind of about that history. So okay, Newton's notation is like that, but the dy dx, okay, so the prime is with Newton. The dy dx notation, which we're gonna see, that is used by Leibniz. Okay, the other guy. Each has its advantages and disadvantages. So we have to know both. Okay. You've never seen dy dx before, right? Until now. Okay, what does dy dx kind of look like though? Yeah, it looks like y over dy, delta y over delta x. It kind of is. The d is called a differential, and it stands for it does stand for delta. Okay, it does. That's why it's d. It stands for change, but the d stands for very, 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 very infinitesimally small change. Okay, so that's why it stands for the derivative, because the derivative is delta y over delta x when the delta goes to 0, right? Well, that's what the d stands for. So that doesn't actually equal 0, but it goes to 0, right? So how can I describe that? So df over d, so df dy is the same thing as dy dx, okay, which means the derivative. They're all equal. Y prime, f prime, right? F prime of x. Same thing as df dy or dy dx. Okay, now what does this mean? This is the same thing as delta y over delta x. Okay? Yeah.
Why isn't the first one a delta y in the bottom?
Oh, I'm sorry. I'm sorry. Thank you. You always catch my errors. Thank you so much. df dx. df dx. Yeah, yeah. Okay? So it really means delta y over delta x, but it's the limit as delta goes to 0. Does that make sense? The delta is infinitesimal. Infinitesimal. Isn't that a great word? That's an SAT word, infinitesimal. But it's infinitely small as x goes to infinity. Infinitesimal. It's infinitely small. Okay? That's why that's the instantaneous rate of change, okay? So there are many ways to denote the derivative of a function y equals f of x besides f prime of x. The most common ones are, oh shoot. Okay, I thought these were all there, but I guess I left it blank on purpose. I don't remember. I guess I left it blank so we could fill it in. Okay, so y prime obviously is this. This is in your book. Who has the book? Woo! I love calculus. It's so much fun, don't you think? It is. Okay. So we could call it y prime. This is the pronunciation, okay? We can also call it dy dx. Okay, this is on page 101. We can call it df dx. And my favorite, ddx of f of x. Okay?
So those are all ways of just
Saying the same thing. It's all saying the derivative. Okay, so why don't you go ahead with your partner, kind of read through the pronunciation and the little description, okay? Because you need to know these. The benefits. What's the independent variable? Which one's the independent variable? X. And then I want you to pick your favorite so far. Pick your favorite.
Why prime?
Why? Because it's nice and brief, but it doesn't name the independent variable.
Do I say df, dx, or do I say df?
Don't say over. Just say df. That's technically not a fraction. It kind of is a fraction, and it acts like a fraction, and we can treat it like a fraction, but it's not really a fraction. Okay? So, of course, if my function was not f of x, let's say the function I'm using is g of x, then you would say dg dx, right? And Sky asked a good question. We don't say dy over dx. You don't have to, like, that takes too long, first of all. And it's not, we do treat it like a fraction, but it's not really a fraction, okay? It's just, it's a notation to mean derivative. With respect to, get used to saying that and thinking about with respect to, okay? That's a big one. Okay, cool. Let's go on. All right, so now it says graph f prime of f prime from the graph of f on the same set of axes. This is kind of like what we were doing yesterday, you guys. So I want you guys to do this with your table right now, okay? With your table groups. Perfect, we're in groups. It's a little complicated, but I want to see how you guys do, okay? You're too strong for your own good. Do the next two problems. Okay, hurry up though because we have to finish the lesson. Yep. Like the green dot. Yesterday, it's like you're graphing the green dot. The green trajectory. Because I gave you the function, now you graph the derivative function. Find the derivative. What's the slope of the tangent? Think about the green dot. Pick a point. No what? That makes it easier. Okay, let me start you off a little bit. Come on, I want you guys to kind of struggle with this and figure this out on your own. But then again, there's time. I mean, there's no time. So yes, this is like the blue graph from yesterday, and I want you to draw the green graph, right? The derivative graph. So you have to pick a point, and you have to kind of think about what's the slope, the tangent at that point. Luckily, you don't have an equation, so how are you going to calculate the derivative? You can't, except by looking at it, right? But luckily, these are all linear, right? So between here and here, what do you think is the slope of the tangent? Like if I pick -4 right here, what does the tangent look like at -4? The tangent, it has the same slope, right? The tangent here.
Attention teachers, just a reminder, those students that need to be dismissed to go take the pictures, you can dismiss them now. Also seniors, there's a meeting today. It's going to be in room 19. The room has been changed to room 19, which is Mr. Pulgarin's room. All seniors are welcome. Once again, article before in the following clubs: hip hop dance, 9th grade tutoring with Miss Romero, SRLA with Miss Williams, cheer with Miss Santillanes, guitar club with Jack in room 22, visual arts with Miss Lopez, and bodybuilding and light fitness with Danny and Mr. Alvarez on the blacktop.
Okay, so the slope of the tangent is whatever the slope of the line is. The slope of a line, the tangent is just the slope of that line. Its derivative is itself, right? So what is the slope of this line? It looks like it goes up 2 and over 3, right? It looks like 2/3, can no? No, it doesn't.
Yeah, it looks like one.
Oh, wait, over.
Oh, yeah. It goes up 2 over 4, which is 1 up over 2. Okay, so the slope is 1/2, right? Right? So if the slope is 1/2, what is the f prime? 1/2. Where though? In this whole interval, the slope is 1/2. Okay? Now, right here, is it going to be 1/2? Actually, no. So this is going to be an open circle, but your green line, or green dot, whatever, your derivative, should look like this. Oops. Okay, because the slope of this line is the slope of the tangent, which is 1/2 the whole time. It's constant. It's like going at the same speed the whole time. If you are getting away from some place linearly, that means you're walking at a constant speed the whole time, right? Then they went closer to the original position. That means they turned around, went backwards, right? That's why the velocity, or the derivative, is negative. What's the slope of this part? -1. So the slope went to -1. So the derivative went to -1 this whole time. Right? And then what happened? What's the slope here? 0. So the slope went up to 0 in this interval. And then what's the slope here? I think it's 2 over 1, right? So the slope went up to 2 in this interval. Okay? So there is our function, graph of f prime. It went down, it went up, it went. You guys see what we did there? Why did we put open circles? Okay, so like right here, what is the derivative? Well, okay, it's just like limits. You got it had the left and the right have to match. If the derivative from the left is 1/2, but the derivative from the right is 1, then there actually is no derivative at x equals at this point. Because how would you draw a tangent? You could draw it this way, or like there's too many what? You know, like on a corner, if you're trying to balance a seesaw on it, there's many angles, there's many tangents that it could have, right? So on a corner, there is no actual tangent or derivative. There's no derivative at a corner like that. That's actually called a corner. Okay, and so that's why there's an open circle there. There's no derivative. There's a one-sided derivative. A left-hand derivative is 1/2. The right-hand derivative is -1, but at the point, there's no derivative. Okay? That makes sense? And then here, based on that information, if I give you this information, you should, and I give you a starting point, you should be able to find me the graph of the original. If I give you the green line, then you should be able to give me the blue line.
The green line is second.
Yeah, the second one. See, this is the green one. Well, just based on yesterday's example, and this is the blue. Can you give me? Yeah. So we're not out of time. So tonight you're gonna just finish your homework, but I want you to finish your notes too. So I want you to do this problem. Okay. Think of it as a challenge problem, but it's a very good problem. You'll see. You'll need people have difficulty with graphs, analyzing graphs and derivatives. So do practice this. So what is the derivative of x equals 2? The left-hand derivative does not equal the right-hand derivative, so the derivative at x equals 2 does not exist. Okay? Hold on, you guys. Write this down. Write this down and write this down. This example, I want you to do it on your own. I want you to look at the example in the book, which is very similar. Based on the example in the book, I want you to fill this out. Okay? Okay? And then I will just do like a 3-minute video, okay, for you to finish these notes. Okay? And then everything else you're filling out on your own. Okay? So look on Schoology for a short video and then fill everything else out on your own using the book. Got me?